And we are now recording. Okay, so time-wise, I think we're quite good, up to 5.1. And if I count everything out, if I just leave 5.1 for this week, and even if I don't finish it, we only have 4 more sections after that and 3 weeks to finish. So 5.1, 2, 3, 4, and 5. So even if I just go down to 2 sections per week, that's going to be sufficient. Okay, that being the case, for today and tomorrow, I'm hoping, I'm not positive, but I'm hoping to leave you a little bit of time. So in case anybody wants to ask me questions pertaining to the test on Friday, you may. So keep that in the back of your mind. So again, might end at, quarter to, or 10 minutes to, in which case I'll let you ask anything about the test. Again, Thursday is dedicated just for that. I'll let you ask all the questions you wish on Thursday, but maybe today, maybe tomorrow also, since I don't have to go that fast on my original schedule, mark actually a little bit ahead, and I still have all these extra days, buffer days that I have. Okay, so keep that in mind in case I stop abruptly, quarter to, 10 to, and say, okay, I'm done with today. Does anybody have any questions about the test? Then you can do that, okay? All right, reminder, so our next test is Friday. Coverage is 4.1 to 4.8. I'm already finished with 4.9. It will not be on this coming test. I'm starting 5.1. It will not be on this Friday's test. It'll be on our last test. Okay, so all we have after that is the last exam, which I'm hoping for Thursday the 20th. Then we have a final exam on Monday the 24th, and then we're done with the course. Okay. All right, so any quick questions about that? Let me check the chat. All right. Okay, so yeah, anybody who joined, go ahead and put your name in the chat. I've already put away my attendance, but you guys know the rules. Just put it there so I know that you showed up. Okay. All right, so I'll go on and do 5.1 stuff, but I might just stop after a while and ask if anybody has any questions pertaining to the test. All right, so where were we? We're trying to find area under a curve, 5.1. Okay, so we started off with a graph of y equals x squared. Looks like we partitioned, chopped the region up into 4 equal subintervals from 0 to 1/4, 1/4 to 1/2, 1/2 to 3/4, 3/4 to 1. Then we took rectangles. Okay, so here are rectangles that are too big. Here are rectangles that are too small. What's so good about doing a rectangle? I know how to find the area of a rectangle. Okay, I don't know how to find an area underneath something like that yet. Okay. Now take a look at this picture. It's really the same thing. Instead of chopping the interval from 0 to 1 into 4 pieces, they chopped it up into 8 pieces. So notice they go 1, 2, 3, 4, 5, 6, 7, 8. So this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7, and same thing over here. Okay. So my smaller subintervals, a subinterval is an interval that's part of a larger one. The original interval was from 0 to 1. A subinterval is from 0 to 1/8, 1/8 to 2/8, 2/8 to 3/8, and so on. Okay. Suppose on each subinterval, I pick the left endpoint, meaning I take the left endpoint, go straight up until I touch the graph, draw a rectangle. Well, this is the origin 0, 0, so my height is 0. Okay, between 1/8 and 2/8, I'll go straight up 1/8. If I plug in a function, it's 1/8 squared. I get that rectangle, and so on. Keep using the left endpoints, and so on and so on. All right, so that'll give me an underestimate. Okay, the sum of the areas of the rectangles will be some number. I know how to find the area of a rectangle, and it's too small because the white space is the area that I'm losing. Right, I lost that area and that area and that area and that area. Right. That comes out to be 0.27, blah, 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 blah. So the true area is bigger than that. In this picture, they picked the right endpoints. So between 0 and 1/8, they pick 1/8, go straight up until you touch the graph, draw a rectangle. Between 1/8 and 2/8, they pick 2/8, go straight up until you touch the graph, draw a rectangle. Same thing all the way through. Here's the last one from 7/8 to 8/8, which is 1. Pick the right endpoint, which is 1. Go straight up until you touch the graph, draw a rectangle. So I can find the sum of the areas of these rectangles, base times height, base times height, base times height, all the way through, add them up. It's clearly too big because I got this extra area and this extra area and this all the way through, 0.3984D, whatever. Okay, so I know the true area is between these two numbers. Okay. Now, if you look at what we did last time, 4 rectangles, we had 0.46875 and 0.21875. So the true area was between those two numbers, 4 rectangles, 0.21, 0.46, not very good, of course. 8 rectangles, 0.27, 0.39. It got better. Okay. What's going on in this table over here? N gets bigger and bigger and bigger. So the N means chop the region from 0 to 1 into 10 pieces, 20 pieces, 30 pieces, 100 pieces, 1,000 pieces. Imagine taking the interval from 0 to 1 and chop it real finely, okay? If you can imagine using the left endpoint or the right endpoint won't vary that much. And notice the bigger the N, the closer L sub N, the sum using the left endpoints, and R sub N, the sum using the right endpoints, get. So for 10, 0.285, 0.385. Okay, 20, 0.308, 0.35. You notice they're getting closer and closer. And look at all the way down to 1,000. They are really, really close. 0.3328, 0.3338, and so on. Okay, in each case, using the left endpoints, you get a number that's too small. Using the right endpoint, it's too big, but the numbers get really, really close to each other. Okay, we would even say they converge to each other. Okay, in fact, it looks like it comes real close to 0.33. And what nice fraction is that? It's about a third, right? Okay, and there on the bottom says the area is about 0.333335. Okay, which seems to indicate the true area would be somewhere around 1/3. Okay, now of course you don't want to do that by hand, but a computer can do that very easily. Okay, and maybe some of you computer science people, your computer science instructor might have you do such a program to simulate, using the left sums and the right sums on such a situation as that. Okay. Figure 7. So they chop it into more and more pieces. Notice again, the sum is too big, but the extra amount gets smaller and smaller and smaller. Okay, and then on page 369, look at what's happening for different N's. N equals 10, 30, 50. Look at N equals 50. There's very little waste at the top, right? So 0.385, a lot of waste at the top. 0.35, not as much. 0.34, you can barely see that extra stuff at the top, right? Likewise, for the underestimates, you're looking for that white space, right? The white space that did not get included under the curve. N equals 10, N equals 30, there's less. And look at that, N equals 50. That white space, it's still there, but it's barely visible, right? And so by the time you get to N equals 1,000,000, the approximation gets better and better and better. Okay, so that's the concept that we have here. So when N gets bigger, officially, mathematical wise, when N approaches infinity, right? When N approaches infinity, the left sum and the right sum approach the same number. Okay. In general, page 371, look at figure 13 now. This is the most general case, which we're not going to do. But here's a function. We're trying to estimate the area under the curve from A to B. Okay. They chop this region up into so many pieces. This picture is 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. So the original interval was from A to B. You have several sub-intervals, smaller intervals. from here to here, here to here, here to here, here to here, and so on, right? Notice all the rectangles they picked. So what they're saying is on each sub-interval, smaller sub-interval, pick a representative point to be the point that represents the entire sub-interval. Go straight up until you touch the graph, draw a rectangle. So see this point over here? They just picked some random point, frankly, between the left endpoint and the right endpoint. Go straight up, draw a rectangle. This one, it looks like they picked a point right in the middle, midpoint. Straight up, draw a rectangle. This one maybe looks like it's 3/4 of the way across, straight up, and so on. This one's in the middle, 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 this one's in the middle. This one's, I don't know, maybe 3/4 of the way across. Okay. Add them all up. It's an approximation to the area under the curve. Okay. So technically, you could pick any point that you feel like in the subinterval. Okay. We will only choose three, the three most obvious ones. Okay. We're going to pick either the left endpoint, the right endpoint, or the midpoint. We're not going to fool with a point that's 1/10 of the way over or 3/4 of the way over. Okay. So we will pick either the left endpoint, right endpoint, or the midpoint for our pictures. Okay. And not bother with anything else. Not that there's technically anything wrong with the others, but less convenient. Okay. All right, so back to more pictures here. Y equals e to the negative x. Okay, here they're picking midpoints. So we're trying to find the area under the curve of e to the negative x between 0 and 2. They chopped this subinterval up into 1, 2, 3, 4 smaller subintervals, right? So each subinterval has a length of a half, 0.5, 1, 1.52. Okay, and then on each subinterval, it looks like they picked the midpoint. So 0.25, 0.75, 1.25, 1.75. You don't have to write that down. Those are the midpoints. Okay, they go straight up, draw a rectangle, straight up, draw a rectangle, straight up. Okay, look at what happens if I pick the midpoints. It's most of the time going to be a good approximation. Okay, because notice this white space was supposed to be included. That got left out, but I added this extra piece here. Okay, so there'd be some sort of cancellation. Does that area exactly match that? May, it may not, it probably won't. Okay, but it's a pretty good approximation. Same thing over here, right? I'm supposed to get that white space, but I'm not supposed to have that blue space. Same thing here. I should have the white, I should not have that blue. I should have the white, should not have the blue. So the midpoint tends to be the best of the three approximations. However, can I say for sure whether it's an upper estimate or lower estimate? No, I can't tell. It depends on whether this area is bigger or smaller than this one, right? Okay, so for using the left sums or the right sums, you can usually tell, okay, do I have an upper estimate or lower estimate? Okay, the midpoints will tend to be the best estimate, but you don't know if it's going to be too big or too small. Okay. Okay, so finally going to get started with one problem and see how to do it. So on the homework, I have here 1, 2, 3, 5, 7, and see if that matches what I had here. Yeah, 1, 2, 3, 5, 7, 13, 15, 17. So I should do number 2 for you. Let me do that. Number 2, use 6 rectangles to find estimates of each type for the area under the given graph of f from x equals 0 to x equals 12. Okay, and your problem number 1 is very, very similar. Okay, a little bit of notation. So 2AI, L6, R6, and M6. L stands for left endpoints. You're picking the left endpoint on each subinterval. R6 means you're taking the right endpoint, and M6 means you're taking the midpoint. Okay, so in order for me to do this one, I actually have to write on it, and I don't want to write on my book. So what I did instead was I made a photocopy of the book. And I don't mind writing on, except it's not in color. Okay, it's in black and white, but hopefully you won't mind too much about that. All right, so L, R, and M stand for left endpoint, right endpoint, midpoint. The 6 stands for your N. How many pieces am I chopping this up into? Okay, it says go from 0 to 12, 0 to 12. 6 pieces, then what is my delta X? Okay, you're going from 0 to 12, 6 pieces, my delta X is 2, right? So delta X equals 2. So here we go. We'll go like so. Now, what are we trying to estimate? I'm trying to estimate the area under the curve. So go straight up, curve down, down here and over. This area here, it's curved. So right now it doesn't seem like I can get an exact answer, but I get an approximation. Okay, chop it up into 6 pieces. 6 pieces, the length is 12, so delta X is 2. 2, 4, 6, 8, 10, 12. Right? Maybe I'll just write in 2, 4, 6, 8, 10. Okay, so I will draw my regions like so. Like that. And like that. Whoops, I had bad aim. Maybe I should go like this. Okay. 1, 2, 3, 4, 5, 6 regions. Boy, this aim was pretty bad. Still can't get it. Anyway. All right, I'm going to pick different colors here. So, first one, 2AI, L6, left endpoints. Okay. So my subintervals are from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12. Okay. 0 to 2, what's the left endpoint? 0. Left endpoint. Go straight up until you touch the graph. Draw myself a rectangle, and I think I'll change colors here. I've got it in green, so it's a little bit too big. Okay, between 2 and 4, what's the left endpoint? 2. So go straight up until you touch the graph. Draw a rectangle from 2 to 4. And keep doing that. From 4 to 6, left endpoint is 4. Go straight up. Between 6 and 8, left endpoint is 6. Go straight up until you touch the graph. Probably easier if I just freehand it now. Keep going. 8 to 10, left endpoint is 8. And 10 to 12, left endpoint is 10. Okay, so can you see these 1, 2, 3, 4, 5, 6 rectangles now? Add them up. Base times height, 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 base times height. Okay. All the bases are the same though. What's the length of every base? 2. Right. 2 times. Okay, now for the heights. These are just kind of eyeballing it. Okay, that looks like 9. 2 times 9. Next one is 2 times, well, it's a little bit lower than 9, right? About 8.8. Next one is 2 times 8. One, two, three. Fourth one is up here. So where's here? A little bit higher than 7. I'll go 7.3. Okay, 2 times 9, 2 times 8.8, 2 times 8, 2 times 7.3. Okay, fifth one, 2 times, I'm going to call it 6. And the last one is 2 times 4. And it might be kind of hard to read. Let me put parentheses here. Paren, 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 paren. So that's the first area, right? 2 times 9. Next one is 2 times 8.8, 2 times 8, 2 times 7.3, 2 times 6, 2 times 4. Okay. Notice it's very tedious to do it this way. Why don't I just factor out the common factor of 2 and then add up all the heights? 2 times 9, right? Plus 8.8 and so on. 9 plus 8.8 plus 8 plus 7.3 plus 6 plus 4. In fact, this is the preferred way of working the problems out. Okay, just take the delta x, factor it out, and then take the sum of all the heights. Okay, so the heights were 9, 8.8. Then I said 8, 7.3, 6, and 4. Okay, so let me just punch this out of my calculator. 9 plus 8.8 plus 8 plus 7.3 plus 6 plus 4 is 10. And then multiply that by 2. 86.2. Okay, so my approximation for the area under the curve is 86.2. Is it an under or over estimate? Look at the picture. Do I have too much area or too little area? It's too much, right? I'm not supposed to have this extra space here, nor this, nor this, nor this, nor this, nor this. Okay, so it's an over estimate. All right, now for R6, I will have to switch colors. Okay, so R6. Same thing, except take the right endpoint. So between 0 and 2, I pick 2. Go straight up. Draw myself a rectangle. And it's a little bit too small. Same thing between 2 and 4. Pick 4, go straight up and draw a rectangle. Likewise, too small. They're all going to be too small. Between 4 and 6, right endpoint is 6. Go straight up. Same thing, 6 and 8, pick 8. And 8 and 10. And 10 and 12. So I have this in black ink. So that's the first rectangle. Second, third, fourth, fifth, sixth. It's clearly too small this time. So 2 times, and now the heights. So that one we already said was about 8.8. That one was 8. And we already said that was about 7.3. And that one was 6. And that one was 4. And here's a new one. That height is only 1. You may notice the in-between numbers are all the same, which makes sense. Okay? Because the right endpoint for this calculation becomes the left endpoint for the other calculation, right? So notice 8.8 matches, 8 matches, 7.3 matches, 6 matches, 4 matches. The ones that don't match are the very first one, which was a 9 for L6, and the very last one, which was 1, R6. But if you look at all the in-between ones, it makes sense that they match because the left endpoint in one scenario is the right endpoint for the other scenario, isn't it? Okay. Like if I take this rectangle right here from 4 to 6. So how about take the height of 4? The height of 4 happens to be the right endpoint for the second rectangle, but it's also the left endpoint for the third rectangle if I'm doing the lower sums, as you can see. Okay, so all these guys match. Okay, and what does this come out to be? 8.8 plus 8 plus 7.3 plus 6 plus 4 plus 1 is 11. And then times 2, 70.2. And that is clearly an underestimate. All right, so there we go. Now, M6, that's going to be a little bit tougher. I mean, it'd be nice if I could get rid of this, but I can't. Or if I made another copy of this, I suppose. But I take the midpoint. So what's the midpoint between 0 and 2? 1. What's the midpoint between 2 and 4? 3. Between 4 and 6, 5, and so on. Okay. Imagine going straight up for all the midpoints. Okay. It's probably easiest in this particular case to show you the last one between 10 and 12 because I have enough elbow room here. So what's midway between 10 and 12? 11. So let's see what color I have not picked. Blue. So for 11, go straight up. See that one in blue? And that's probably going to be a pretty good estimate because I lost this area here, right? I'm supposed to have that area, but I gained this area. Looks like the amount that I gained is bigger than the amount that I lost. Okay. Right. That same principle works for all the others, although as I move from right to left, the picture gets a little bit more cluttered, but I'm just going to have to show it to you anyway. So between 8 and 10, I would pick 9. So go straight up from 9, draw a rectangle. And between 6 and 8, pick 7. Go straight up until you touch the curve. Draw a rectangle. Between 4 and 6, I pick 5. Go straight up until you touch the graph. Draw a rectangle. Between 2 and 4, you pick 3. And that's why this last one is barely indistinguishable. Between 0 and 2, you pick 1. Go straight up. Okay, so the things that I have in blue are the rectangles formed when I pick the midpoints. 1, 3, 5, 7, 9, and 11. Same thing, base times height, 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 base times height. All the bases are 2, so you factor that out and just give the heights. Okay, so let me see if I can sneak in M6 here, running out of real estate. I'm going to write it way over here. Okay, so now what are the heights here? These are brand new heights. Okay, so that was 9. I'm going to call that about 8.9. The second height, 8.6 maybe. The next one, okay, I'll say it's 8. You might as well pick a nice number if you have a chance. Then the fourth one, f of 7, go straight up here. It's a little bit lower than what? 7, 5, 6, so I'm going to say 6.8 roughly. And the fifth one, f of 9 up here. That's a little bit higher than 5. Say 5.3. And the last one seems to land right on there, which looks like 3. Okay, that's going to be my best estimate, even though I don't know if it's an over or under estimate. Okay. And so let me type that out. 2 times 8.9 plus 8.6 plus 8 plus 6.8 plus 5.3 plus 3. 8.9, 8.6, 8, 6.8, 81.2. By the way, if you're trying to compare your answers, well, I was going to say compare your answers with the back of the book, but I just remembered it's an even problem. You don't have this in the back of the book, but be that as a way. For these problems, you know, I'm just eyeballing it, right? So if you're off by a little bit, it's okay, you know, by a 1/10 or so. Okay, so let me raise this up so you can see this better. All that and all that. Okay. All right, so let's see. So we got our answers. L6, we said was an overestimate. R6 was an underestimate. And D, which of the numbers gives the best estimate? M6, right? You get that cancellation, right? Added area, lost area. Okay, so that's the way that problem works. Okay, so your problem number 1 is very similar. Okay, I'll give you a start to number 3. Let's see, what time is it? Don't have that much time left, but we'll see. Number 3, estimate the area under the graph of f of x equals 1 over x, x equals 1, x equals 2, using 4 approximating rectangles and right endpoints. Sketch the graph in the rectangles. Is your estimate an under or overestimate? Repeat using left endpoints. Okay, so give you a start to it. All right, f of x equals 1 over x. From 1 to 2, n equals 4. So here it is. 1, 1, 2, 1/2. Goes like that. They told me to chop it up into 4 pieces. So delta x is 1/4. The whole thing is 1, right? 0.25. 1, 1.25, 1.5, 1.75, 2. Okay, so R4 means take the right endpoints when chopped into 4 pieces. So go like that, straight up, too small. Same thing here, too small, too small. Okay, so those lower rectangles, I'm picking the right endpoint. So base times height, base times height, base times height, base times height. All the bases are 0.25, so factor that out, and then plug into the function. So it's 1 over 1.25, the function is 1 over x, plus 1 over 1.5, plus 1 over 1.75, plus 1/2. Okay, if you punch it in your calculator, it's roughly 0.6345, and that is an underestimate because the rectangles are too small in this particular case. Okay. L4. So on each smaller interval, I take the left endpoint. So I go straight up until I touch the graph, draw a rectangle. That's clearly too big. Same thing for next one. Go straight up, too big, too big, too big. So I'll get an overestimate. So again, base times height, base times height, base times height, base times height. All the bases are the same, 0.25, factor it out. The function is 1 over x. So I take 1 over each x's left endpoint. So 1 over 1. The next left endpoint is 1.25, 1 over 1.25. The next left endpoint is 1.5, 1 over 1.5, plus 1 over 1.75. Add them all up, about 0.7595 is what we got. Okay, that was as much as I was going to do for now. We only have about 10, 15 minutes left. Okay, I was going to let you have some time for question and answer. Now, if you have a full-fledged curve sketch, I'm not sure I can get to the whole thing. Okay, but I'll stop the lecture here and see if anybody wants to ask anything in preparation for the test on Friday from anything here. So if you want to go ahead and put that in the chat, you may right here. Okay, so anybody want to ask something? Again, you still have, I'm hoping to do the same thing for tomorrow. And then Thursday is completely dedicated for that also. Okay, so anybody want to ask anything now? I'll check the chat. Again, if anybody joined late, please put it down so I can get you. Anybody want to look at any question now? And if not, then I'll just go on. Okay, have a request for 4.721. Okay. All right, let me start that. Maybe that's all the time we got. I think that was a word problem. .721. Find a point on the line, blah, 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 that is closest to the origin. Okay, so we had discussed that before. Okay. 4.721. So line y equals 2x plus 3. Closest to the origin, 0, 0. Okay. Rough sketch, doesn't have to be very accurate. Okay, y equals 2x plus 3, slope is 2, y-intercept is 3. So something like that. So if I want the shortest distance, do I go that way or that way or that way? Eyeballing it somewhere here. Okay. And by the way, some of you may notice you can actually do this problem without the calculus, but we're in calculus. You need to do it by the calculus technique. Okay, not by anything else. Okay, so by the distance formula, which is a variation of the Pythagorean theorem, the square of the distance is x minus 0 squared plus y minus 0 squared. Variation of the Pythagorean theorem, right? So let me call that the function f of x is x squared plus y squared, but everywhere in this line, y is 2x plus 3. And I'm trying to minimize this. Okay. So my function, which is the square of the distance function, is x squared plus 2x plus 3 squared. Yeah, technically I'm minimizing the square of the distance, but if I minimize the square of the distance, I've also minimized the distance. So it's okay to do this function. Okay, you can multiply that out. I don't feel like it right now, so we'll just go with it. Okay, f prime is 2x plus 2 times 2x plus 3 times 2 by the chain rule. 2x plus 4 times 2x plus 3. 2x plus 8x is 10x. plus 12. F double prime is 10. That's greater than 0. Greater than 0 means concave up. So if I have a horizontal tangent at a concave up, I will have a minimum. Am I looking for a minimum? Yes, I am. And you should be able to tell right away there is no maximum, right? This line goes way out there. I can certainly get as big a distance as I feel like. Just pick a point that's way out there, right? So there's clearly no maximum distance, but there is a minimum distance. Okay. So I just set the first derivative equal to 0, and that'll do it. $10x plus 12 equals 0. Okay, so some simple algebra. X is negative 12 over 10, which is negative 6/5. Y is 2x plus 3. 2 times x plus 3. Let's see, plus 3. There's 3, right? So it's negative 12 plus 5, 3/5. Okay, so the ordered pair that I want is negative 6/5 and 3/5. So the answer to this question mark, what is that point that's closest? It's negative 6/5 3/5. Okay. And let me raise it up so you can see it. Okay, and maybe I forgot to do that for this one too. So back to question number 3. I forgot to raise it up. So you can see that. Okay. All right, we have a few minutes. Anybody else have something you want to look at? Let's see, for the word problems, if we get a negative number, that means we're trying to find a max. And if it's positive, we're finding the min. Well, it depends what you mean by getting a negative number. Okay, for the second derivative test. Okay, if you mean over here. Okay, second derivative positive means the graph is concave up, and that means we have a minimum, if that's what you mean, yes. Second derivative negative means concave down, and that means the maximum. Okay, for the second derivative. And let's see if I can highlight for you real quickly. We are at page 297, second derivative test. Okay, A, first derivative is 0, second derivative greater than 0, local maximum. Part B, first derivative equals 0, second derivative less than 0, negative, then we have a local maximum. Yeah. Okay. Okay, 4.714 quickly. Not sure if I can do this that fast. Let's give it the old college try. Box with a square base and open top. Okay, I may just have to set this up and then leave it at that. Since I think I already did this. Correct me if I'm wrong, but I believe I did this problem before. But let's see. 4.714. X, Y. Okay, square base, open top. And the volume is 32,000 centimeters cubed, which is x squared y. So you know you can solve for y, right? That's generally the game plan. So y is 32,000 over x squared. And then minimize the amount of material used. So we have area function a of x is x squared plus 4xy. The bottom is x by x. The four sides are all x times y. There's four of them. And then you just substitute y. Y is 32,000 over x squared. And then it looks like the x's cancel out. So you have x squared plus 128,000 over x. And we're trying to minimize this. And I think that's just about all the time we have for now. Okay. But I'm pretty sure we did it. You can check back on the videos that we did this one. And yes, for this kind of word problem, x should be positive. That was not true here, right? It was on an XY coordinate plane. So you are allowed to have negative values for x and y here. Okay, well, even before you start it, you kind of can tell that x should be negative, y positive. Okay, here it's a word problem. Distances are always positive. So ignore any negative answers for this one. And before you take the derivative, right, this should be 128,000 x to negative 1 and go from there. Okay. All right, but I think that's about all the time we have for today. All right, so I'm going to stop here. So tomorrow I'll probably do the same thing. I'll lecture for a little while on 5.1, but then at the end let you ask questions. And Thursday I'll let you have the entire time, and then the test is on Friday. Okay. All right, so that'll do it for today, folks. So everybody have a good day, and we'll see you next time. Okay, bye everybody.